Hello my dear students, in the last part we have discussed about the Prism formula and we have solved numerical problem based on Prism formula. And in this part we have to discuss about the small angle of prism and we have to derive a new formula of angle of deviation produced by the small angle of prism. Angle of prism is small big Prism na produce over angle of deviation ki magi delta ki anoba formula ma ko derive asi tawdo ne ko adugi derivation to lower kanda ko tong dispersion of light through a prism the light na white light na far kanda masu taret 7 different color splitting to the ko adugi maramda ko discuss tawdo that is dispersion of light or white light through a prism has it. Object prism ki angle of prism that is refracting angle ze am pick target di prism na produced over angle of deviation ki formula ze kamaina legi do ko je yeng ko so akoy to angle of deviation produced by a prism of small angle of prism ko sai prism ji sagi angle z that is refracting angle or angle of prism je the pick target di sagi prism na produced over by angle of deviation give formula to put up first we have to see this ray diagram, that is a ray of light is passing through the prism and here mu represents absolute refractive index of the material of the prism, that is glass to ni sidale mu is na prism ki absolute refractive index to ni and sida ladiba light rays PQRS mamang do si figure je dum yekre ko hanjana jana yam yekre aduna sida ladiba symbol mayam je masagi usual meaning lere I is the angle of incidence on the first refracting surface AB lere R was the angle of refraction on the first refracting surface AB lere R2 is the angle of incidence on the second refracting surface of the prism formed by the refracted light ray inside the prism, that is PQ on the second refracting surface AC. See the light ray QR now second refracting surface AC have the refracting surface formed over angle of incidence to the R2 is the angle of emergence. So the delta is angle of deviation, that is angle between incident light ray PQ and emergent light ray RS when they are produced. So the delta is incident light ray PQ ka emergent light ray RS ka bag leba angle to ni apoi ko produce or kan intersect hole aduga angle putu pa yare delta le ko is na angle of prism to ni ada apoi julau to is sida leba capital A angle of prism hai ja kari ba yam the pick pa angle oram tar ga di sai delta ki formula se kamaina leiga dagi ha bi ni apoi mamang da delta ki formula se putu kare delta equal to I plus E minus A no ko amai puthok re adudagi lakadu ni ma anu go formula ma anu sida apoi yana laktu is sagi sigi figure je yam explain tawdra su ko ju laktu is sigi first refracting surface A bisida stage law apply tawrani adu stage law dagi apoi na sagi angle of prism je kari bu yam pick pa targa di delta value je kamai na lakadage do apoi je yeng sim ko first we have to write like this. Let us consider a prism of small angle capital A and mu be the absolute refractive index of material of the prism. A ray of light is passing through the prism along the path PQRS as shown in figure. Or see figure is the full is in it. When the prism that is small ABC is in it. E is the mark small angle of prism where I see prism is the light ray fall along the path PQRS in the but the last is I is the angle of incidence, R was the angle of refraction on the first refracting surface. E be the higher kaduni. I was there with me now. See prism absolute refractive index. So next we have to write like this: I and R1 be the angle of incidence and angle of refraction on the first refracting surface. E small AB. And the see first refracting surface E visible by angle of incidence na I way angle of refraction na R1 way applying Snell's law, we have see the first refracting surface that we know Snell's law apply to our Snell's law is sine of angle of incidence divided by sine of angle of refraction equal to relative refractive index of karamba sagi refracted light ray saliba medium long tare, that is prism to the prism have the glass to the ko aduga eastern light ray na laiba medium to na yearly adu na sitala constituency my irani relative refractive index of glass, that is prism with respect to ear hydrogen ko adu sida relative refractive index of glass with respect to ear hydrogen absolute refractive index of glass that is absolute refractive index of material of the prism. Snell's law apply to sin I by sin R1 equal to absolute refractive index of material of the prism, that is mu, and write it equation number 1. And method is I the R1 that is angle of incidence and angle of refraction there. See angle since we am the pick never. Angle of prism capital A Z. Ya pick target the angle of incidence ka angle of refraction. Since you the picture lakani. Aduna angle since am the pick target the sin I Z approximately I logo yai, sin R1 Z approximately R1 tang logo yai ko. Aduna if the angles that is I and R1 are very small, then sin I should be approximately equal to I, and sin R1 will also be approximately equal to R1. Aduna sila riba sin I mota I tang irani, sin R1 mota R1 tang irani. Aduna matangi step tamu yesko. Matang da smile ibe since A, that is angle of prism is small, angles I and R1 are also very small. See angle is a pick target the cos the I ga R1 sinju jam pixel lakani aduna sin I is approximately I irani, sin R1 is approximately R1 irani. Aduna masapan equation number 1 do adagi smile ani I by R1 equal to mu. This implies that I height ardi mu R1 smile ani, and write equation number 2. Next we may write like this: R2 and E be the angle of incidence and angle of emergence formed by the light ray on the second refracting surface AC. Again applying Snell's law, sin R2 by sin E equal to relative refracting index of ear with respect to glass. See figure is the R2 is na angle of incidence on the second refracting surface AC inside the prism duni, E is na angle of emergence duni. Aduna sigi AC have second refracting surface da koina Snell's law mu apply to kanda sagi sine of angle of incidence ID sine of R2 lani, sine of angle of refraction have this the angle of emergence is lower ni angle of refraction ka adum samane or sine R2 by sine E lani equal to relative refractive index of ear hierarchy maram the refracting light ray RS ear medium layer ear the ko incident light ray QR is na prism man graduni glass aduna apina constancy imatamda relative refractive index of ear with respect to glass hydrogen aro sigi ear the glass ka japon interchange to tardi reciprocal ani 1 by absolute refractive index of glass or relative refractive index of glass with respect to ear, that is sigi symbol siga samane 1 by mu la ne adura masai maina sidala riba R2 ga E ga ju small angles na to oigani aduna sin R2 mota R2 irani sin E mota E ka ko irani aduga akoina mu use in terms of R2 ga E ga dum piba yani ko adu mata step to yegase mathang the smile irani since R2 and E are also very small angles, sin R2 approximately equal to R2, sin E approximately equal to E. Aduna masai ko net phang bamang phang equation number 2 do smile ani sin R2 mota R2 irani sin E mota E dam ko irani aduna R2 by E equal to 1 by mu laire alo sidagi E equal to R2 mu laire and write in equation number 4. Next slide na masai gi sigi prism jina produce over angle of deviation je delta aduni adu delta form as smile ani angle of deviation produced by the prism is given by delta equal to I plus E minus A. See formula is the amount derived tawre adugi formula the lakpani smile losulani angle of deviation je delta oitardi delta se kai manare angle of incidence plus angle of emergence minus angle of prism smile ani aduna kasai koina fangi ba equation number 2 ga 3 2 ga 3 ga da fangi do equation number 4 ga 2 ga da fangba equation number 2 da na I p gare I equal to r1 mu even adu equation number 4 da na e is r2 mu sijale adu sidala riba angle of incidence I ga angle of emergence e ga mota koina r1 mu aduga r2 mu na sijal ani ba ko equation number 2 ga 4 ga sizdar ga sida sijal ka doini matam ana koina mu iba yari se sagi hojiki mamangi equation du lakoni delta equal to I plus e du mota r1 mu plus r2 mu irani minus a using equations 2 and 4 ko और सिद्धि r mu common लौरो और r1 plus r2 लाए minus a then r1 plus r2 जम करी मानेंगे वो angle of prism का माने सीजो कोई मामांगी formula दा derive तो करे और सी r1 plus r2 मोटा angle of prism a ने सिंचलानी अदुगा मु a से common लौरो अदुगा mu minus 1 times of a लानी अदुना equation number 5 से कोई पामी से delta equal to mu minus 1 into a सीनी कोई ना angle of deviation produced by a prism of small angle है इसे और सिगी formula जे derive सिगी formula जे apply तरो कांदा कोई मतंग दा numerical problem अमक यंगसी को question जे मु यंगसी calculate angle of deviation produced by a prism of small angle 6 degree calculate refractive index absolute refractive index of material of the prism is 1.5 और सिदा p जे सगी small angle of prism p 6 degree अदुगा prism do sarai ba material do gi absolute refractive index no 1.5 pire adu itardi prism do na produce to ba angle of deviation do adu putok to ni ko ana koina yan hana pitoi ji kari ke no hana koina irasi given the there is a small angle of prism do ni that is 6 degree lai re adu ga mu je pire mu equal to 1.5 akoina pami je delta putok po do ni delta ko smile ani we have delta equal to mu minus 1 a smile there adudi the mu is the law 1.5 minus 1 6 smile line form the angle of prism do yapti tar ko see from as section na rani the 1.5 minus 1 the 0.5 into 6 line ko the 0.5 to 6 multiply the already 3 tar ko 3 degree tarni 3 degrees by tarni so now we have derived angle of deviation produced by a prism of small angle and we have solved one numerical problem based on that formula aduga akoina hojik mathang ki part hai tare ko ase gi sida dum isalani mathang ki part na sagi dispersion of light ki matang da koi discuss tauji that is white light se akoina prism da pass all of tardi prism dagi tholak iba there is emergent light rays into there is emergent light of beam haisu light emergent light rays into the masu tare yorkani there is 7 different colors adu ki combine na adu split away no dispersion of white light se kari no have maram da mathangi part mu koi amu discuss to na